Everything inside liquid is present. Okay, I'm going to spin it. Okay, I think no, none of the ends. So he's given assume zero pressure at the axle. Then he's asking, okay, what is the method involved in such problem? So you assume a small elemental disk. This also I did in regular class. Check notes once. Some small basic concept is there. Rotating fluids. Okay, now we'll take small elemental disk. Dx at a distance x. Tell me where pressure should be more. So it's a simplest idea. This liquid will have a density rho. So mass of this dm omega square will act. And because of this here, the pressure at this particular point, this one here, if it is P, this will be P plus dP into area. PS get cancelled, so the dps will balance dm omega square r. What is dm? So let's do one thing. dps equal to dm. There's a very small, or you can say important concept. Some around 15 numericals are there related to this. Not 1, 2. What is dm? Dm equal to rho s dx omega square. Okay, this is, I think, dr. I'll write it. Radial distance is telling, no? Okay, that s will get eliminated. So dp is equal to, we'll write one more step here, rho omega square r dr. Let's integrate this. Okay, fine. The pressure in fact will vary. Similar to like a gauge pressure here. In the rotating liquid, there's a gauge pressure. Finish, or how we have in vertical column rho gh, no? For rotating liquids, it will be rho omega square. Where pressure will be more here or here? At the axis or at the edge?
Edge.
At the edge, pressure will be more. This is very important. If it is a rod, no, the tension will be more here. The pressure will be more at this particular point. At put R equal to 0, here it will be 0. Anyway, yes, put a condition, assume 0 pressure. Now, if I make a small hole, what do you expect? See, try to take this one. These questions are there in Edo. Possibility of asking. Now, if I make a small hole, what do you expect? Yes, the liquid will start emerging through that particular hole. Then we can discuss Bernoulli's theorem and we'll work out the problems. All are interrelated. All these ideas are interrelated. That's what I feel. Now this is rotating. If I make a small hole, okay, I need diagram. Huh? Let me finish off that concept here only. Huh? It will be easier. Okay, so a small hole I made. Okay, because of this small hole, now the liquid starts coming through this hole, no? Can we calculate the speed with which the liquid emerges here? So here it is air. In that case, what we should do, I should apply Bernoulli's theorem between 0.1 and 2. What is the pressure at this point? We know rho omega square r square by 2. And what is the speed of the liquid? Okay, what is this V? Velocity of the emerging liquid with respect to tube, because it will also have tangential velocity. With what speed the liquid will emerge with respect to tube? Because it will also have tangentials, am I right? So they may trouble you with these ideas. Please, this liquid, how it will emerge? It will not just move, it will flow somewhere. Suppose say if this is the tube like this, here the liquid what happen will take parabolic path because weight mg will act. The jet what happen will move parabolic path. It will just not will not move like this. Am I right? It will have one component of velocity along x along negative z axis. Why negative z axis? Because of tangential velocity. The resultant of that will make the liquid to move in this way and weight will act. The jet will go in this direction. So they may ask you questions of these things where students should imagine all. Apply Bernoulli's theorem between 1 and 2. So pressure at 1, 0, it will be a test. The moment I open a ball, pressure at 2 plus 0 plus rho VR square. What is pressure at 1? Rho omega square r square by 2. Let L be the length. In that case, it will become L square by 2 equal to pressure is P naught rho VR square by 2. If he makes any here some all or anything, no, you can put atmospheric pressure P naught, then that P naught can get eliminated. Fine. So these are the some things you remember. So this is VR. Okay, let's come to this one. The centrifugal force on any water element must be balanced by field pressure force. I think that's what I started, no? The very basic equation. If a lighter particle was in the fluid, it will have a tendency to get accumulated towards center. Definitely. Or will it be here? If a lighter particle was in the fluid, it will have a tendency to get accumulated towards center. I think it should be a no lighter particle, mass will be less. So they'll get, if a heavier particle open, the mass will act, it will be the heavier particle will be here, lighter particle will be here. Let me add that. Oh, multiple ideas, lighter particle, heavier particle, if any are subs, are like a, are there in this particular rotating liquid column, no? So